Welcome back, everyone. I hope you had a chance to grab dinner or lunch, in my case, breakfast. I'd like to introduce myself, and then then I will introduce my panelists one at a time, and then hopefully we'll have some time for Q&A at the end. My name is Wendy Ju. I'm an associate professor of information science at the Jacobs Technion Cornell Institute at Cornell Tech. I've been faculty since 2018, and I look at how people interact with automation, including robots, autonomous vehicles, and cities. We have a really wonderful panel today on looking at data and visualization, just ways to really understand what's going on in the city. And we're going to lead off with a presentation by Anthony Townsend. Dr. Anthony Townsend works at the intersection of urbanization and digital technology, and he's urbanist in residence at Cornell Tech's Jacobs Institute. His research focuses on scenarios and ethical frameworks for urban tech innovation. He's the author of 2 books, Ghost Road, Beyond Driverless Cars, and Smart Cities, Big Data, Civic Hackers, and the Quest for a New Utopia. So he works with people in industry, government, and philanthropy on urban tech foresight, policy, and planning studies, and is going to be talking to us about the NYC Bus Watcher. Anthony, are you ready?
I am. I'll just fire up the screen. Hello, everybody. This has been a really exciting day so far. So what I'm going to talk about is not, can we see my slides? Is that, okay. This is not a research project yet. This is a research project in the making. What this is a combination of curiosity and opportunity that was realized through what we have at Cornell Tech called a specialization project course, which is basically, I think of as like a sort of a pair capstone project that's done in the spring and the fall between spreading the 2 years of the master's degree program with sort of a double course load in the fall. So students get to map out a project in the spring, and then they get to really kind of scale up the intensity in the fall. And I actually had 2 groups working in parallel. Because of sort of the way it worked out, it ended up being a total of 3 students. And so what I'm going to do is sort of share the evolution of this process and what we've learned and where we're heading, and why I think it's important for people who are interested in exploring urban data, but also doing it with students. So I said this was opportunity. 2020 was a big year for the New York City bus system. We had massive shifts in service because of the shutdown, overnight shutdown of the subway system. We had a lot of essential workers that still had to get back and forth to hospitals and other locations in the middle of the night. And so the bus system really evolved. Lots of changes in operation due to social distancing. So it was just a really, really difficult year for planning and delivering the service on top of all the other challenges. Along the way, occupancy sensors were installed in about 40% of the buses. It's a really good technology that doesn't measure Bluetooth beacons. It actually measures human beings getting on and off the bus. It's very accurate, very reliable. It's not completely deployed, but this data is now being pushed out through the real-time feeds. And this was something that obviously was incredibly important in understanding what was happening in terms of crowding last year. And there's also a lot of infrastructure improvements in terms of bus lane rollouts, restricted access, other kind of electronically monitored and enforced bus lanes, as well as priority signaling systems that turn the light green when a bus is coming down the corridor, that were meant to improve bus travel speeds throughout the city and improve the service. The other thing that I didn't mention in here is that there was just a lot less traffic on the streets. So bus speeds improved dramatically across the city, and people got to see what bus service would be like if buses weren't stuck in traffic all the time, which is the #1 challenge for bus service. So when I came aboard last summer to to the Urban Tech Hub, I was looking for ways for us to get our hands dirty and start working with urban data. And when I, sort of saw what was happening, saw what our opportunities were going to be to work with students and the kinds of things students were interested in, I spent a couple of weekends throwing together some code to scrape and archive the bus feed, the feeds of the real-time location and status updates for the entire New York City bus system, basically on a 60-second every minute basis, so that we would have a repository of data to work with. As I started doing this, everyone that I've talked to about this says, didn't somebody already build this? I feel like I heard about that on Twitter or on a blog post somewhere. And yet the answer is yes, someone did already build this. Transit Center, which is a transit advocacy organization, started a very effective campaign in 2016 called Bus Turnaround. And as part of that, they worked with a number of civic tech groups, including Microsoft's civic tech group, had some very skilled software engineers build a very robust set of tools for pulling down this data, the real-time locations of all the buses, archiving it, and then computing all kinds of metrics in order to boil it down to essentially a grade for each bus line. And I had been looking at this for years. I'd built a similar system for New Jersey. But our first instinct was, okay, let's just use that data because they do make the data available for researchers and others who want to make use of it. But one of the first things we discovered is that that system hadn't been well maintained and that there were some significant outages that mostly had to do with the fact that various pieces of infrastructure, whether it was a cloud instance that was doing the monitoring or a storage bucket that was holding the data, had failed or filled up and no one had noticed. And so what you'll see here is that the lack of coverage, and this is one of students, Jeremy Schaefer, was the first to notice this, and actually brought it to the attention of the Transit Center folks. And you can see there's a 10-month gap, which they were aware of, and then there was another gap that had emerged that I don't think that they were aware of when we notified them. So this was the first of many examples of our students getting their hands dirty with this real-world data and these complex data acquisition infrastructures, and seeing the fragility of having all of this depend on one person who's a contractor to an NGO who may not even be under contract anymore for this project, who may just be maintaining it out of goodwill, and that those things fall apart over time, and that this is data. Ecosystems have to be curated and maintained in order to be effective. We also realized that because of the way that these data archives were being processed, they weren't storing the original responses from the MTA API. They were only parsing out certain fields of interest and storing those. And so we were missing some of the newer data that had been added since the scrapers had been built, including the occupancy and passenger count. And so we built our own parsers in order to pull that data out, in addition to keeping the original responses in case we ever want to go back and pull out additional data that we don't, that we aren't parsing now. This all adds up citywide, sampling the whole system, which peaks out at about 2,500 buses in operation at rush hour every minute, 24 hours a day. It's about 2 million records a day. I don't know for any of you who work with data whether that's big, but it was certainly big enough for us, and it was big enough for our students. One of the things I've found is a lot of students, when they do their coursework, dealing with sample data sets and sort of classroom data sets, they often don't kind of confront the kinds of challenges that they're going to confront in the real world, because data has been prepared and cleaned, for those problem sets and some of the trickier problems, really time-consuming, boring stuff, but important stuff, is dealt with. And so, a lot of these students' work was being done in notebooks on their desktop, laptop computers. And so we had to limit ourselves to, just a week or two worth of data. Some things, training some of the machine learning models just a day. And so that's like one of the big challenges for us going forwards is how do we scale this up to where the students can do this work and really deal with it on a city scale over long periods of time. And we have to build out the infrastructure for that. So Jeremy Schaefer, one of our first year urban tech graduate students, focused on service metrics and focused in particular on a corridor. So he wasn't looking at the entire city, but just this one corridor, one of the slowest bus corridors in the city along East 149th Street in the Bronx. It had been given the Pokey Award by the Transit Center in 2018. Average speed of buses over ground, 4.6 miles per hour. Really, really slow, slower than the citywide average. It was targeted for a big improvement program by the city that was moved up during the pandemic. And so it was put in, and this is part of a citywide campaign to improve the average speed of buses from 8 miles per hour to 10 miles per hour. And those programs are still ongoing. And this directly ties to equity. I didn't really sort of make the case for this because, that is the way that people of no other means of mobility get around the city is on the bus system. Getting back to these data gaps, one of the things Jeremy wanted to do was look at, how travel speeds looked on that route before and after the installation of these signal priorities and bus lanes. And also, he wanted to try to see if he could slice it like before and after the pandemic. As it turns out, we just don't have data during the pandemic period, during the lockdowns, because we weren't collecting yet and the transit center wasn't collecting yet. So what we're going to do in the fall is look at 2019, before the transit signal priority installation, before the pandemic, and 2021 after all of that, and presumably after things return to whatever is normal now. One of the things that I think is really interesting about this and about teaching with this real world data is just the tremendous amount of ground truthing and data exploration that the students did, not to prove anything to me, but to prove to themselves that what they were seeing was accurate and real. And in some ways to prove that my data capture system was actually operating properly. So they really poured over this stuff with a fine-tooth comb, trying to make sure that the frequency of trips that they were seeing, in each these are sort of histograms showing each observation, kind of each breadcrumb. And this looks like what you expect. You sort of see this pattern of rush hours and weekends on each of the routes. We wanted to make sure that the buses were actually traveling along the routes and that we weren't seeing buses in all kinds of weird places where they shouldn't be, indicating some kind of tracking failure or something else. And then hopefully this will work. Jeremy even went and was trying to just do some quick visualizations to make sure that, we were capturing the full track of each trip and we didn't have big gaps, so that when we went to compute things like how fast the bus is moving between each observation, we weren't going to have, our intervals were going to be sort of consistent. And this is several months of work this spring for the students to really convince themselves that what they were dealing with was an accurate representation of what was actually happening in the world. And it didn't just give us confidence that the data was good. It also revealed some really idiosyncratic things about how the bus system works. So one of the things that Jeremy discovered was that there was a surprising number of buses that were reporting that they were making the same scheduled bus run, which should not happen. That should be a unique identification for each trip on the schedule. If you look at a bus schedule, each trip. And so we were trying to find out what are these duplicates. And the way that we, and you can see here, these are basically multiple bus vehicles running the same route with the same trip identifier, which should not happen. And the way that we discovered that was not by digging into the data. It was by talking to a subject matter expert, Eric Goldwyn, who's at the NYU Marin Institute and has done hundreds of interviews with bus drivers and was involved in a big redesign of the bus system network in Brooklyn. And what Eric explained to us is that often dispatchers will hold a few buses in reserve and deploy them along segments of a route that are very congested in order to pick up extra passengers. And they won't run the full route, or they might start halfway through and run to the end. And because the tracking system doesn't really have a way to accommodate this, they basically just punch in the same code for the bus that's already on the trip. And this practice is called wildcatting. There's also just a lot of operator error. And so sometimes operators will punch in the wrong trip number, and the system will assign them to what trip it thinks they ought to be on. So this was really interesting, that this exploration, this ground truthing process of the data pulled us into probably where we should have started, which was engaging the stakeholders, understanding the context of the problem, and really getting a nuanced sense for how the people in the system work. But because we were taking this very opportunistic, very quick start, very sort of data science, curiosity-driven approach, we didn't get to. But I'm glad we did get to it in the end, and it was working together with the students that got there. So Jeremy was reluctant for me to share this with you, but I was so proud of his accomplishments that I wanted to share it. We did, again, because of limitations in processing, we didn't do this for the whole thing, but his first pass at calculating the travel speed is just about, within order of magnitude of what Transit Center had calculated, churning piles and piles larger data. So, I think good first result. Bad news, because it shows that the travel speeds have not improved. So I think we're curious about whether that's going to improve as we look in more depth and over a wider period of time. I just want to share a couple quick slides, and feel free to cut me off if I'm going too long, on another student project. It was done by Lars Kuenhoven, which is a predictive modeling project that's using the passenger count data to see if we can predict the number of passengers on a bus, basically given the time and location of the bus. And Lars focused on the M15, which runs, up First Avenue and down Second Avenue in Manhattan, and did some similar kind of ground truthing just to make sure that it made sense that buses are empty at the beginning of the route and they get crowded when you get to Midtown, and then they empty out as you get uptown. And he built a machine learning model, trained it on 3 weeks of data, and had some reasonable results. Got sort of within 5 passengers. There's some interesting technical caveats around this. We had to start to model the bus system network itself, because passengers can't get on and get off in between stops, so it's not really a continuous variable. And then some of the runs that he did, some of the models that he built, actually turned out to be essentially modeling proxy models for whether the bus is following the one in front of it closely or not, which in bus operations you call bunching, and that makes sense. So it was interesting to see the different ways that just sort of coming at it from let's just throw features in and see how close we get, to let's use some domain knowledge to build our model and actually see if the results get better. And then Lars had a big aha in the last week of the semester.
Anthony, are you close to the summary?
3 slides, yeah.
Okay.
He had a big aha at the end of the semester, which was, what if we built a separate model for each scheduled trip? And obviously much more computationally intensive, but starts to show some real promise as you train those models over a larger data set. And he was able to sort of do a proof of concept for some work that'll continue in the fall. We're also going to expand this work to link to subway disruptions. So his ultimate goal is to build a model that can measure the impact of subway disruptions on crowding of buses that are operating in the same area. And that's an incredibly useful thing. Just so one more slide. Our third student, Jamie Gang, who is looking into how all this can be visualized and turned into dashboards that both people who, professionals in the transportation industry, as well as citizens and researchers can use. And so Jamie is building a variety of different tools that will allow anyone to see the data, select slices of it, and then pull extracts of it out for their own uses. So this is a proof of concept. Was it something that we could quickly spin up and learn from? And I think the three big learnings were, well, I'll skip the first learning because it's not worth going into at this point. But I think the biggest takeaway was not rushing this ground truth thing. This was some place that we learned a lot technically about engineering, and we also learned about how the city works and the quality of the data and why the data quality suffers from in the ways that it does. And students just became passionate about this. It was digging into that complexity, motivated them. It didn't discourage them, and it drove them towards some meaningful results and learning as well.
Thank you so much, Anthony. We'll get a chance to stay on this topic of visualizing transportation data with the next talk. Professor Carol Martens is a chair of the graduate program in urban and regional planning at the Faculty of Architecture and Town Planning at the Technion, where he also heads the Fair Transport Lab. And his research interests include the nexus between transport and justice, transport and land use interaction, and parking dynamics and policies. His book, Transport Justice, Designing Fair Transportation Systems, has been described as colleagues as groundbreaking, a landmark, and a revolution. And he's going to be talking about COVID-19 and the duties in transport. Are you ready, Carol? I see you frozen. I don't know if that's just me. Okay, great. I see you moving.
I'm not sure because I missed indeed your last few sentences, but I assume you asked me to start my lecture. As my connection dropped, I hope it will be okay. I put on the hotspot as a backup.
Okay.
You can see my presentation?
I can, yep.
Okay, you can hear me reasonably well?
Yes.
Okay, actually I won't be talking too much about COVID in the end. And I also hope I won't upset Anthony too much with what I'm going to say. I really enjoyed this lecture and I'm very happy to be here and connect to all the people here. So I'm going to talk about how we can use big data to enhance transport justice. I think Anthony's work is working exactly in the same direction, analyzing how buses perform and improving their performance will certainly make many people that are poorly served at the moment by our transport system better off. But my message is slightly different. So big data has been embraced by the transport research community as an opportunity to have much better data. We have been relying on travel behavior surveys. They're extremely expensive. It's very difficult to conduct them regularly. It's very difficult to get a representative sample. It's very difficult to get data on your specific region, and so forth and so forth. So transport researchers and practitioners have been very, very happy with big data and doing much work. And this is one of the company from the Netherlands with whom I'm working. And they use mobile phone data from about 25% of all Dutch citizens from one provider to map their travel patterns and actually to predict COVID-19 infections. And they were pretty successful by doing that. I won't show that results. But basically, what we're doing with these data is analyzing trip patterns, analyzing visiting patterns, analyzing tourists coming into the country and so forth. And here, for instance, they are comparing regular trips, recurring trips versus occasional trips. And as you may expect, occasional trips are longer and they tend to focus more on the Randstad area, which has the big cities, Amsterdam, Rotterdam, which are of course visited by many people, both for business on an occasional basis and for recreation. An example from a colleague in Milan, analyzing activities based on mobile phone data and showing differences between the workday and night activities. And you see indeed completely different centers of activity, but somewhat overlapping also. This, of course, is vital information if you want to adjust your transport system and your public transport system especially. And perhaps what is most disturbing me, I mean, I appreciate this work very much, but this work has been embraced by the transport modelers who've been terribly busy for decades building travel demand models to predict future travel flows. And they have embraced big data. And we just last week had a one-day seminar in Israel. How can we use big data to improve our national demand model so that we can better predict future traffic flows? Now, my problem with that approach and focusing on the trips we see is actually what is the purpose of those analyses? That is basically is providing supply for the demand we see. And so we're very busy with matching supply to demand. And in a way, matching supply to demand is what the market does. And the market does it very well. It uses the price mechanism to make sure demand and supply are always in balance. We don't have a price mechanism in transport, so we have lots of transport modelers that are helping us to match supply to demand. And basically, we're recreating the market system in our transport system, which I think is highly problematic because we know that the market serves those with money well and those without money much less well. Now, the demand perspective was directly translating to what many operators did in COVID times. Demand dropped, and so services were cut in many places. Many places also, of course, there was an outcry about it, a pushback, and services were reinstalled. But the tendency to respond to demand changes by changing your supply is inherent in current transport approach and highly problematic. And if we use big data like we have used travel behavior survey, my argument would be we're making the same mistake. And so we should seriously think about what is the duty of government in the field of transport. And I think COVID has helped us to make this more clear. I think if there's one thing that the COVID has made clear is that travel is essential to get to all kinds of destinations. It fulfills an essential tool to fulfill your needs and wants. And I think transport planners have forgotten this, typically seeing it as a demand rather than a need. And demands, well, you don't always have to fulfill them, but needs have to be fulfilled. Actually, I think that in some cases and some transport agencies, COVID has changed the perspective, have made them realize that we have been delivering supply to where demand was and not realizing that there are needs that are not very well served. So COVID has done some very good things. I think the second starting point should be that the idea that travel is a choice, which is basically the basic assumption among behind all travel demand modeling, is true for some of us and not for a small part of the population, but is for many people not true at all. They are much more constrained. They're constrained in mode choice. They're constrained in destination choice because only a few destinations are reachable within reasonable time and comfort and money. And they are even constrained in actually getting to destinations. And so we should be aware of those constraints. Now, something also very fundamental in my perspective is that it doesn't matter whether you're rich or poor, we are all dependent on collective investments. There is no transport system that doesn't require government intervention. There's no road being built, even if it's a toll road, without government support, without government protecting and guaranteeing the right of way. And if government is so essential, and if transport is a collective investment, then I think the fundamental question should be, what do we owe to each other? And I don't think matching supply to demand is what we owe to each other. No, we should go back to those needs and wants. Now I'm going to get to the big data part. So in my book, I try to answer what we owe to each other. Whether it's groundbreaking is up to you. I won't summarize the book, just one sentence, which is very obvious. The conclusion of the book: every person is entitled to a sufficient level of accessibility. So If you think this is intuitively appealing, great. Because the idea of a lengthy philosophical argument is not to prove intuitions wrong. It's rather to see whether intuitions also stand up to reason. And I think they do in this case. So probably we should embrace this principle as being something intuitively appealing and also being able to defend it on rational grounds. Now, if every person is entitled to a sufficient level of accessibility, the purpose of transport is in a fundamental way to provide freedom, because accessibility to destinations, being able to get to a range of places, is basically a freedom. It gives you the freedom to do what you want to do, to take up this job or that job, to meet that friend or another friend, to go to that doctor or another doctor, or to get to a doctor at all. And so transport is about providing freedom, and mostly about providing freedom to all. Okay, now, so how can we use big data? So I already said big data in transport, there are mobile phone data, there are app-based data, GPS-based data, they track our behavior. They basically show what we are doing. They're therefore tracking demand. And we can still use them in a different way. If we just, instead of measuring travel behavior and better mapping our behavior, which they certainly do, in contrast to surveys and traffic counts and so forth, we can also use them to measure travel problems, would be my argument. And for this, we have to change our perspective. So for those people still from the analog era, they might know that this is how a picture looks. This is the positive of a photograph, right? And behind it in the good old days, we had a negative, the inverse of the picture. Now in big data, it gives us the picture, but it can also give us the inverse if we analyze big data in a different way. If we use them to see what is not visible in the data, but what is implicitly there as the negative of travel behavior, the lack of behavior or the problematic trips that people are making. And so the challenge is to use big data to move from travel patterns to travel problems. And I think there are two generally patterns we could try to identify. One is of forced immobility, people that want to travel to destinations but don't do so, or much less than they want to, or in a very tedious way. I think we can use this data. But there's also the other medal, and that makes it a side of the medal, and that makes it difficult. There's actually forced hypermobility, people that have been pushed out of cities, but their destinations are still in the city. Their job is there, or vice versa. They are stuck in a poor neighborhood and their jobs have moved out and they have to travel very far. So both few trips made, few distances travels might be a problem, as well as long distance travel might be a problem. And so this makes it very difficult to, I think, identify problems. Because what we observe might be a choice, or might be the result of constraints, and people might live in Manhattan, have a car even, and pay huge amount of money for an expensive parking place, but hardly ever leave the house because they're just happy sitting in Manhattan and people come to them. That makes it difficult, but the argument is, I think, that big data contains so much data that you can actually extract, lots of indicators that jointly might enable us to identify people that have serious travel problems. And so if you take a typical travel behavior data, then we would have extract from that origin and destination. We have the travel time, we have the distance, we know how long people stay at a destination, we know the departure time and so forth. If we have a more advanced system, we can sometimes extract mode from mobile phone data. If we combine it with GIS, we can even extract travel motive because of land use patterns. There's much data there. And these data in themselves do not tell us whether you're not traveling is a choice or a constraint. But if we start combining them and unraveling them, we can actually generate all kinds of indicators that might suggest travel problems. So, and which these I call indicator variables. So this is just an example, but for instance, we can just start tracking people over a month and see how much trips do they make during the day, during the evening, during the night. Now, clearly, if we're very mobile and we have a car available or we have plenty of money to hire a taxi or a ride share, we would see relatively, we also might make trips in the night. Now, if we have less opportunities, we might see this drop. We can combine it with travel destinations, people that still travel in the night but only go to work might be a different issue than when they travel to leisure places. We can map travel distances. People travel over long distances. We can combine this with travel time and see how quick is their effective time. So how long does it take them to travel 5 miles, 10 miles? Is it an hour or just 10 minutes? This tells us a lot about the challenges they may have. And if we combine many of these together, linked to one ID, we might be able to actually identify people with travel problems. So we didn't use such a big data set as Anthony, only 350,000 trips. This is actually a traditional travel diary combined with a GPS tracker. So nearly 40,000 people had a GPS tracker for 1 or 2 days, and jointly they register all their trips, 350,000, and we started analyzing them. And we're just in the beginning. Rasha Bobierat is on my team to analyze this data set. I'm not a data scientist. She's not a data scientist, so we have a major challenge of making progress. But like Anthony said, when people get into it, they get enthusiastic and they don't let go. So just some first analysis. She's very interested in whether walking can give people actually access to key destinations. And so she started analyzing, first of all, the ratio of all trips versus walking trips, trying to map where people walk relatively a lot. So we see some areas where people make nearly all their trips, the very dark blue, nearly all their trips by walking. This might be a sign of excellent neighborhoods to live in. Everything is there. It might also be a sign of travel problems, no other opportunities, poor public transport connections, low car ownership, and so forth. Then she analyzed, now let's see where are the areas where there are no internal trips. So people cannot stay in their own neighborhood for trips. They don't make any trips in their own neighborhood. Everything crosses the border. And now this might be a sign like there's nothing in your neighborhood and walking won't give you the answer. Now, if you only focus on walking trips that stay internal, you see even more areas that do not have any trips that stay internal, suggesting that if you don't have a car, that many everyday destinations for which you don't want to go on the bus maybe, and you don't have a car, you don't want to pay for a taxi, well, you might have problems in this area. And the surprising thing is we see this also in some areas which are presumed to be more walkable. So this is just a first step. And as an illustration of what we can do, you can generate huge amount of indicator data. By smartly combining them, I think it would be possible to identify pockets or people who might be facing travel problems. Combining this with socioeconomic data might identify areas being poorly served, what kind of trips are poorly served, and that might then help you to design better transport systems. This is the long-term vision of this work. The link between analyzing the travel problems and having solutions is not such an easy one. Like it is with travel behavior and saying where you have to put an investment, right? You know the behavior of today. It doesn't tell you where you have to put the supply tomorrow. We invent travel demand models for that, and then cost-benefit analysis to assess it. We have to have a whole series of models, analytical tools to move from big data to travel problems to interventions. So to conclude, if we want to use urban tech and then especially big data for social impact, I think we should realize the potential of big data. And I honestly admit it took me time. I was skeptical about big data. I would be reproducing reality rather than to be used for something else. It took me time to realize, wow, we can use it for something else. And but we have to ask the right questions to do so. If we ask the same questions, we will deliver the same solutions. And we will use a navigation system to avoid the traffic jams, but that's not what transport is all about. For you personally, yes, but not for us as a government, as a collective. And we have to see through the data. So there is data, but there's hidden data in the data if we analyze it in a smart way. So that's it from my side. Thank you for your time and attention.
Thank you, Carol. The next speaker actually is continuing on this transportation And actually following up on this idea of how transportation affects social and economic well-being, Dr. Nicholas Klein is an assistant professor in architecture, art, and planning at Cornell, and his research examines how access transportation enables economic and social mobility, and he's going to be talking about GoFundMe campaigns for buying and repairing cars. Nicholas, are you ready?
Yeah, I'm ready to go. Hi, everyone. Thanks to those other other panelists and those great talks to lead off. I'm excited to be on this panel with Ryan, Anthony, and Carl. Ryan, I don't have your book yet because you haven't written it yet, but I have the other two's books. I think Carl, your book is back here in this pile somewhere, and Anthony, your book is at home. I'm gonna talk today. I changed my talk to fit a little bit better in this this panel, not what I proposed. I'm going to talk about a paper I did last year with 2 students, and I'm gonna, I think it's motivated by a lot of what Carl and to some degree Anthony is talking about like whether data and the methods that we often use in transportation planning can answer the questions we want to ask. And I think often, not my esteemed co-panelists, but others in transportation planning and academia, ask a lot of the same questions over and over again, right? And use the same data over and over again. And I think I'm really interested in sort of looking a little bit askew and saying like, how can we ask questions that I really care about, that many people care about, that maybe policymakers, maybe they care about. So I'm going to talk a little bit about a project I did that. It uses a little bit of visualization. It is not big data. Well, I mean, sort of, it's like reaching into the big data to extract a small portion of things that might be interesting to me. So let me share my screen and I'll start. Great, so I assume you can see something. Let me pull up the chat so if people have questions, I can try and answer them. All right. Chat is here, and I'm gonna post a link to the paper in case anyone wants to stop listening to me and just take this to read on the beach. This is a paper that I'm talking about that was done with a master's student in planning, Min Tran, and Sarah Riley, who's a PhD student in information science here at Cornell. As I already told you, you can have a link to this good beach read over here. And I'm gonna talk about why I'm interested in this. I think, sort of building on what Carl was talking about, right? We think or we hope that government and society provides transport or enables transport that provides freedom. And often it doesn't. And what do people do then, right? And I'm going to talk about one example of how people try and navigate those questions, right? When government isn't providing sufficient transportation. Some background, we know from research I and other people have done that low-income households frequently transition into and out of car ownership. These transitions are not well understood. And part of that is because of what data we have, right? We have a lot of cross-sectional data, right? That tells us whether people have a car today, right? Doesn't tell you anything about whether they had a car yesterday or they're gonna have a car tomorrow, right? We have very little panel data that sort of provides that kind of detailed analysis that we really want to construct people's narratives, right? Of their life histories. And so I really want to learn to sort of ask, what can we learn from crowdfunding campaigns about precarious car ownership, right? About why low-income households are transitioning into and out of car ownership frequently, right? And what it means for their lives, right? Because, to get at this question again about why do we ask these questions, like, I actually don't care that much whether someone has a car or not. I don't care whether someone takes the bus or not. What I care about is like, what does that enable them to do? How does that enable them to live their life? Those are the questions we actually care about, right? Like I often talk about, I don't care about the road, I don't care about the bus. What I care about is the people on the bus and what's happening with their life and what that means to them. So you all probably know a little bit about GoFundMe. It's been around for 11 years now. It has become even more prominent in the past year, right? In the US, a lot of it is used, sadly and unsurprisingly, for medical medical expenses, which is again a reflection, right? This is GoFundMe, and what people are using it for are like a mirror to our society and tells us something about what's not being provided, right? And largely in the US, that's medical healthcare. Right. So when I was doing this, I was like, how easy is it to set up a campaign? It's super easy. You can set one up in minutes. You receive the campaigners, unlike Kickstarter and other crowdfunding campaigns, you get the money whether or not you reach your goal. So if you raise $10 out of a $20 campaign, you get $10. If you raise $10 out of a $2 million campaign, you get $10. There's a small fee associated with it and a transaction fee. So what data did I do and how did I get this, right? So with the help of the PhD students, a PhD student on the project, we scraped campaigns, right? For a bunch of searches that we thought would be relevant after looking through and trying to identify, what would be the good search terms. And so we identified the URLs associated with these search terms. And then we scraped data from each of these pages. So we scraped the title, the narrative, the amount raised, the goal, the number of donations, the locations, right? So some really interesting information. Right, and so on GoFundMe, there are millions and millions and millions of these, right? We scraped only 1,028. And of those, we then actually manually went through, right, talking about what Anthony's saying about like, okay, you have a lot of data, like, is it valid, right? And so we had to just get rid of a couple hundred campaigns that were not related to cars at all, right? We were interested in people using campaigns to purchase or repair a vehicle, right? A private vehicle. And so we further whittled it down to 335 campaigns created after 2008, where people received at least one donation, right? Like, we wanted to have some sort of barrier about like, are these campaigns like legitimate? And like we said, like, if you have a donation, that counts. And we looked at ones that had no donations, and there's not a huge difference, right? Maybe those ones tell us something else about that person's social networks, their social capital, but we didn't see a huge difference. Of these, 226 were worth for car purchases, 78 for car repair, and 31 for other campaigns. The median campaign the goal was $2,000. They raised, the median raised $200, right? So most people aren't raising what they set their goal as, but that's okay in GoFundMe, right? They get that money anyway. My question was not whether they achieved their goal, but like other questions about what's in their narrative, right? And most people had a modest number of donations. These campaigns mapped onto where people live, right? We have populous states, right, which are Texas, California, Florida, New York, Ohio, and so forth, right? There's a little bit less in New York, but not a meaningful amount, right? I analyzed the distribution between population and campaigns, and it's like very, I forget what the correlation is, it's very high, right? So it tells us, it makes sense, like about where people live. So in terms of methods, I used two methods. So first we did some text mining. In R, we use the tidy text package, which I really like, which takes these different, we focused on the title and the narrative. We did try to do topic modeling. Frankly, for the data set and what we were doing, I did not find it helpful, right? I'm sure others more skilled in topic modeling would have found this more helpful or would have done more with it. We did it, and I said, I was like, okay, it tells us something, but it wasn't really hugely informative in a way that I was looking for. It didn't tell me much about the precarity of car ownership and what's happening with people's lives. So we also did a qualitative analysis, right? So we had a corpus of 330 some campaigns, and like, I really wanted to code them all, right? It's not that many. We can code them all, and we can probably learn a lot, and I'll talk a lot about that. And so we used MaxQDA, which is a qualitative data analysis software. And we focused on 3 themes, right? Like, and these are relevant to policy and planning, right? Like, these are things we care about, right? Why did they want a car? What was it? What was the purpose of doing it? What did they want to gain from it? What were the precipitating events, right? This is something we don't actually know in transportation research about, what happened? Why did they lose the car, right? And then also the broader context, which is a theme that sort of emerged doing this research, right? We hadn't predefined this, we hadn't thought about this before, but there's a lot going on in people's lives that intersect with their transportation resources. So what did we find out, right? And so I'll just quickly go through this. So first I'll talk a little bit about the text mining, but what do we find in campaign titles, right? What are the common word pairings? And I can present this as a graph, right? We see the title of my paper, desperately need a car, right? Like people, you see things about their emotional state, about sort of emphasizing that they really need a car, timeliness about it, a little bit about their positionality, a single mom, single mother, right? We also did the same thing with campaign narratives. And these are all in the paper if you want to sort of pour these over in more detail late at night, right? And so if we look at sort of the campaign narratives, right, we see a lot more data right here. These are, I think, word pairings that were used more than 5 times. And a lot of them, we see a big sort of nexus around cars, right? Which makes sense, right? And we did some ground truthing, like what were people talking about these? What were the most common words, blah, blah, blah. And we find a lot about sort of, the reliability of the car, about insurance, about repairs, about transportation, public transportation, right? And this was useful before we did some of the coding to sort of see what are some themes we might use, right? And I like this idea of pairing these two methods of text mining with qualitative analysis, right? They're not, to me, they don't replace each other, but they work well in together. So I want to talk first about why campaigners wanted cars, right? What did we learn from the qualitative analysis of the campaigns, right? And why campaigners largely wanted cars for many of the same reasons that most Americans want cars, right? To travel to and from work, to access school, to access medical care, to chauffeur their children, right? So people wrote in their narratives things like, I've lost my job, not having a car has crippled me from working to pay my rent and bills, right? Many of, traveling to and from work was the most common reason in 60% of the campaigns. And, campaigners really highlighted the economic consequences of losing access to a car, right? The focus on the effects of losing a car, it really contrasts with the literature, which really focuses on the positive effects of gaining a car. Once you got a car, were you able to get to job? Were you able to get to work? Were you able to earn more money, right? And this literature, this data set allows us to sort of look at the flip side of that, right? What does it mean to lose a car in the United States? Right after that, accessing medical care, chauffeuring children, school trips, social family travel are common. Accessing medical care, again, was very common, and this probably reflects the fact that maybe it's a population bias of GoFundMe data. Maybe it's a reflection of the people who are using it. Right, a third of campaigns on GoFundMe are for medical care. But I think it also reflects the importance of these trips in these narratives, right? Campaigners talked about their struggles, missing medical appointments and delayed care as a result of not having access to reliable transportation. I'll just, let me just sort of look at Carl's question. So some people lost a car and some people were looking to gain a car, right? There were both groups of people in the data set, right? So some people were out without a car for a long time or had never had a car and wanted to access a car. And other people, like their car broke down or they had a gap in car ownership and they were looking to sort of get back to where they were. Right, so another theme motivating campaigns was a lack of transportation options where they live, having to walk long distances, high costs of transportation, other options, the social stresses of borrowing cars and asking for rides was a big theme. And then finally, for a small number of campaigns, right, they had these people, it was about personal safety, right? People who identified as queer, as trans, as homeless, as domestic violence survivors, right? They wanted a car for safety, right? So they didn't have to use public transportation. So they could get away from an abuser, right? Some of these kinds of reasons, right? This was a small number, but really meaningful for them. And they told really compelling stories. Right, and so here's a quote from someone: life as a trans couple is expensive and difficult. Public transportation in Savannah is also dangerous due to their identities as the LGBT community there is harassed and openly aggressed daily. A car is essential to their lives, their abilities to make money, attend work, and travel only great length if they need, or if the need arises. Right, and so I thought, again, right, we can focus on the data, but I think it's really important to tell these meaningful stories as well, even if they're a small number. So let me transition quickly to talking about precipitating events. Right, right? In 74% of the cases, we were able to identify an event that led someone to create a campaign, right? They said, here's why, here's what happened, right? Some people didn't do that. They just were like, I need a car. Nothing about what happened in the past. And what we find is the most common reason GoFundMe campaigners were without a working car was because an unexpected event combined with financial insecurity, right? These two forces, like, my car broke down and needs a new transmission, but I can't afford it, right? These kinds of events, breaking down, crashes, unreliable cars, stolen cars, result in car losses precisely because these people have limited means. When the same events were to happen to me, right? Like if my transmission breaks, it's not a problem, right? I can afford to get it repaired, and I can afford to get a rental, or the insurance company is going to provide me a rental, right? That's not going to lead to a crisis in my life. It's not going to lead to me losing my job. It's not going to lead to me not being able to get around, right? And many campaign narratives characterized their cars as unreliable, noted how often they broke down or they needed frequent repairs. These unexpected events are financial shocks for these campaigners, right? And this is in line with research on working family spending. So Jonathan Murdoch and Rachel Schneider described these events as economic shocks, noting the size and timing of these repairs are unpredictable, but the effect of their eventual occurrence is not, right? Like if you buy a cheap, unreliable car, it's going to break down, right? But you don't know when, and you may not have the means to address that. In the campaign narratives, we also observed how job losses, medical crises, housing insecurity cascade through people's lives, right? So the quote above describes how one campaigner's car was repossessed, his brother's job was at risk, and their housing was at risk after some unexpected expense. In the campaign narratives, transportation was one of several of the challenges in campaigners' lives, right? So 38% of them also mentioned one or more of the following, a chronic or pressing medical condition, taking care of someone with a medical condition, job loss, loss of a home or other housing crisis, loss of a family member, breakup or domestic divorce, right? And so these things are also happening within the people's lives and what's going on, right? It's not that this is an isolated event. For many people, right? And appeals for car repair and purchase often evoked campaigners' deservingness of a car to get to work, to go to school, to receive and provide medical care. These campaigners situated these unexpected events in the context of people's deservingness as hardworking, grateful, and resilient individuals. And the campaigners, they have always promised to make good use of the money, right? They're not going to buy some fancy car, right? This person said, I'm not going for anything fancy, just something reliable so as not stranded and having to walk in the cold or put a strain on my job. All I want is to be able to safely get to work so I can put in the hours, pay the bills, and make sure my daughter's taken care of. I just want to be a good mom, an employee, and to be able to get where I need to go to get things done. So I'll just wrap up and say, a couple of things about what I take away from this from a transportation policy perspective, right? First, our findings contribute to our understanding of households' precarious grasp on car ownership. We find that in a majority of crowdfunding campaigns on GoFundMe for purchase and repair, campaigners were without a functioning car because they could not afford to repair or replace a car after an unexpected event, right? These findings help explain previous research that low-income households go into and out of car ownership more often than affluent households, and why life events have different effects on gaining and losing access to a car for low-income and affluent households. And I think, to get back to the sort of question I started at the beginning, right? Like, we can't answer these kinds of questions. We can't understand precariousness of car ownership with the traditional data sources we use, right? Census data, household travel surveys don't ask these kinds of questions about past car ownership, about what else is going on in your life. They don't tell us about the effects of these kinds of things and what happens to them. And so we have to think, if we want to ask questions that I think are more compelling, right, in line with sort of what Carl was talking about, we have to look at different data sources and ask different questions. So thank you very much.
Thanks, Nicholas. So Ryan Thomas is about to speak next. He's a visiting lecturer in Cornell's AAP regional city and regional planning. And thematically, it's a little bit of departure, but he's also talking about precarity, but instead of thinking about economic precarity, really thinking about climate risk and how we do environmental mapping and planning. So his talk is titled Climate Risk Mapping in Contexts of Informality. And this kind of fits in with his larger research, which analyzes environmental, social, and economic values often hidden within methodological alternatives and best practice methods. Ryan, are you ready?
I am. Let me just pull up my screen share. Right, so yeah, this is sort of a departure in terms of the theme on transportation from the last 3 presentations. I've been kind of taking notes to try and bring it back. And I think actually thematically, a lot of what was discussed, links up very nicely. So I'll just get right into the presentation and try to save some of those questions, some time for the questions at the end. So first, I just want to, particularly because we're sort of doing a context shift and a theme shift in terms of now we're sort of moving into context of informality and sort of developing country context where instead of dealing with big data, typically the problem is thought of as a lack of data. In fact, that's one of the characterizations of informal settlements and informal processes is that they're either intentionally or unintentionally unseen, unmapped, invisible to the state, to researchers and decision makers. And then also that we're dealing with a more of a kind of environmental and a land use planning discussion as opposed to the transportation we've been talking about. So I just want to introduce the concepts of sort of climate risk, vulnerability, and equity, and why this is a suitable topic for a conference on technology and equity. So when we're talking about land use decision making in context of informality, the central concept there is usually like vulnerability. And so vulnerability, we want to target land use investments in terms of infrastructure and say settlement upgrading to the most vulnerable people. And so that's how equity is conceptualized typically in the context of climate adaptation. So you might see this equation. I think of it more as a definition that vulnerability is the interaction between risk and adaptive capacity. So risks being something that's valuable that could be subjected to or exposed to a hazard, and adaptive capacity being the ability to detect the risk, which is what I'll be talking about today in terms of risk mapping, and then the ability, which could be social or economic, or access to, say, state resources that can allow you, a household or a neighborhood or a city overall to adjust to the risk. So again, I'm going to be focusing on the spatialization of risk and how that's done in a context where the data doesn't yet exist. And then bringing this kind of relates a bit to what Dean Yoon was talking about in terms of sort of a simplified just decision model for the smart, sort of data-driven, smart kinds of decision environments that we aim for in urban planning, which is where there's a sort of assumption that more information and data leads to more informed action or better decisions. And we can sort of make a different presentation about how that happens in different contexts and why that's not necessarily the case, but at least that's the goal. And in the context that I'll be talking about, it's really how risk mapping and the interaction with adaptive capacity can lead to vulnerability reduction. So this is the kind of goal, the normative goal of the project, the specific project that I'll be talking about. So I'll be talking about a project that is ongoing in Dar es Salaam. And the first approach to modeling flood risk, which we need to know to sort of set the stage, is that in a very simplified way, in order to build a computer model for flood risk, which is that sort of better information piece of the puzzle, you need data about the built environment. not just sort of the lay of the land in terms of what's where, but also what is valuable to communities and to functioning of urban systems. And so I list here, for example, sensitive land uses and drainage infrastructure as two really key pieces of that information about the built environment. And you also need a digital elevation model, which hydrologists use to model under different precipitation scenarios where water would back up, what would be at risk of flooding. And once you overlay those two layers, the land uses and the areas that are at risk of flooding, you can estimate what's at risk where and how much risk, and then target investments to mediate that. The last piece of the sort of conceptual puzzle to before I start talking about the specific project is just to briefly discuss the context of informal settlements and climate adaptation. So the UN estimates that about 1 billion people live in informal settlements. Adaptation and that these settlements are, can often be coastal or built in parts of the city where land is inexpensive and already at risk. And so people are constantly adapting and building small walls, fortifications against flooding. And the settlements themselves are often changing due to migration. This is often the first place that people live when they move from a rural area to an urban area. And as I mentioned previously, not only are informal settlements characterized by a set of physical conditions that I was just talking about, but also this relationship to the state whereby they are either unseen or there's a lack of data, particularly what we might think of as official data, so government-held databases about informal settlements. And that relationship between the data or the seeing of informal settlements and their ability to be upgraded or to gain recognition and citizenship rights is precarious, because mapping informal settlements can be, in some cases, to the benefit of residents, but in other cases, that information can be used in exploitative ways by the state to relocate people and to, rather than targeting, as I was talking about before in terms of climate justice, rather than targeting investments that would benefit settlements, actually using that to relocate settlements or to target other areas of the city for vulnerability reduction. So to tie this, really wanted to tie this presentation closely to the development of the decision-making and data collection technologies that have been developed. So how is the risk mapping actually done? What are the technologies, the sort of digital technologies, but also the political technologies in terms of organizing people and cell phones and drone aerial imagery and things like that? How is that done on a really tangible basis? So I'll talk about some of those technologies, and then how did we get into a situation where these are the technologies that are available? So how did the framing of the problem, which I think is what the other panelists have talked about a lot in terms of how does the framing of the problem drive the development of new technologies? On the first question, there's sort of a laundry list, and I won't go into each of the technologies, but I'll just talk about a few of them that present promising possibilities in terms of representing informal settlements in a sustainable way for governments to make better decisions. And one of those is OpenStreetMap, which is used as a backend database. You can see the results of a community mapping project in this before and after screenshot, which is the same area in both panels, right and left. But on the left side, you can see that the area appears to be blank, uninhabited, perhaps with some roads, which look a little curious because there aren't many destinations. But then you can see on the right-hand side that this is actually a very densely populated area. And so how is this done? Well, over the course of about 5 years, starting from a student who did a master's project in a very small area, which was then scaled up and was adopted by community leaders who trained their neighbors to use Android phones to collect the location of housing, as well as through drone flights, which captured aerial images that could then be traced. The map of Dar es Salaam is one of the more densely populated places in OpenStreetMap. And the first round of this data collection was focused on collecting the data that was needed for flood modeling. So collecting drains, housing, as well as digital elevation models using the drone, which collected LiDAR digital elevation as well as traceable imagery. So this is a screenshot from the Twitter page of Ramani Haria, which means Dar Open Map, translates to Dar Open Map, that just promoting the success of this project in terms of collecting the location, width, size of drains that enabled flood modeling. And here you can see a blog post of the same project, as well as the outputs of this digital elevation model. So this has been in some ways very successful in terms of enabling computer flood modeling. But interestingly, the community component of this, in which I mentioned that some community leaders had trained neighbors and people who live in these areas to interview residents about flood histories in their own homes. And they, after a number of years of doing this, and sort of after the human component of collecting data reached a certain point, it became more accurate and more efficient, actually, in terms of time, to just ask people where it flooded. And so this became a more of a people-centered way of flood mapping that doesn't rely on hydrology models, but instead relies on people's flood histories, their own accounts of histories. So again, I'll talk a little bit more about some of the other technologies later, and they're happy to answer questions about them. But one of the things I wanted to focus on is, well, what are the applications of these new data that were collected? I mentioned that data can either be exploited or ignored, or alternatively used in sort of progressive planning. And so far, there are two examples that actually exemplify one more progressive and one more potentially exploitative, although it hasn't been implemented yet, in terms of the image that you see on the right, which is a plan to relocate vulnerable residents and rebuild this valley as a green park, and to finance that with high rises, which are in the yellow and red along the edge. So obviously this can be, this sorts to recall histories of exploitation and sort of redlining and things like that Professor Minner talked about a few sessions ago. And certainly this kind of information can be used in that way. However, it's also been used, I don't have an image, unfortunately, for this, but it's also been used in local disaster management plans at the ward level, which is like about the size of a neighborhood, in order to identify evacuation routes and things like that. And stable locations like schools that are not vulnerable, where people can evacuate to in a flood. The other aspect of this is institutional sort of advocating for funding within the different layers of the government within Dar es Salaam, which is the economic capital, but it also has a hierarchical, municipal government, and then ward level governments, and then neighborhood, even smaller neighborhood governments. And some of the government officials who have championed this kind of data-driven approach have sort of bounced around from neighborhood to neighborhood, and use their connections with the World Bank and local universities to produce maps that allow them to advocate to higher levels of government for funding. And so this is a kind of a political capital that some officials are able to access that leads to this kind of patchwork of highly detailed maps, and then some maps that look like the before picture from a few slides ago, where you still don't have sufficient information. So there's kind of unevenness to the mapping. How am I on time? I don't have a running clock here.
You're at time, but you you can have a few minutes more. Everybody talked for about 20 minutes.
Okay, I'll wrap this up very quickly then. Another aspect of this research is to think about how the technologies came about. So in the context of the technologies that I've been talking about, this is a very busy slide, but I'll try to walk it through quickly. Moving from right to left is a rough timeline of some of the adoption of technologies that have been used. And the main point that I want to make in this slide is that it's a messy process in terms of which technologies are available and how they're used. They require institutional and organizational support, the existence of the hard technologies, and pilot projects that test and enable those technologies to be modified. My future research will be looking at interventions into this process at the problem framing level. So how can we, instead of, as I pointed out in this slide, the innovation occurred through crisis, which I won't go into for time reasons, but basically the Haiti earthquakes spurred the development of some technologies, and how can we get residents of informal settlements to be involved in the problem framing. So some of the continuing challenges, this is my last slide, are the institutional perverse uses of data that mean data isn't always used for better decision making, but can just enable people who have access to it to use it to advance their own interests. The sort of selective and partial representation of informal settlements can further exacerbate inequalities within informal settlements. And then the third and fourth bullet points are really talking about making data easy to use through training and decision support tools. And the part that I'll mention last is just this disconnect between the sort of institutional framing of problems as the lack of data and the household risk perceptions. So I'll close with that. Thank you.
All right, maybe everyone can join me in applauding all the speakers. Every single one of them did such a great job, and I'm really excited we have 11 minutes for discussion. I do, since Ryan was just speaking and Carol just asked this question, maybe Carol, you can actually ask your question to Ryan out loud about the definition of vulnerability.
With pleasure. If I recall one of the first slides, Ryan, thanks for the nice, interesting presentation. I had a student doing mobility work in Dar es Salaam using GPS. I was searching for the neighborhood, but it was clearly not those neighborhoods where she worked. Anyway, my question goes back to one of your first slides, where you define vulnerability and you include assets in the definition. Now, clearly, richer people have more assets, so it kind of risks that you bias towards richer people. I mean, clearly assets are also livelihoods and so forth. It depends very much how you define it, and economic assets are easily defined and measured, quantified. Other things more complex. So how do you deal with that? What is normally done in your field?
No, that's exactly right. I might have put, I left it very vague in terms of conceptually, exactly, you're right. How you define assets definitely makes a difference. In this context, assets have been defined differently in different projects. So in the local disaster management planning exercises, assets were defined as, when I mentioned like a school or institutional building, for example, that could serve as an evacuation center where people could go to high ground to get out of the way of flooding. That could be listed, considered an asset. But you're absolutely right. In other applications that higher value land, it can be valued in a way that needs to be, makes it look like it needs to be protected more so than areas where poorer people live and land is not economically valued as highly. So totally agree with your point.
Nicholas, did you want to jump
Yeah, I
in?
have a question for Anthony, if that's okay. Unless Ryan and Carl, you guys want to keep talking about this. As I threatened, I was like, I really want to talk about bus time data. So thanks again for the great presentation. I was wondering, I've dove into the bus time data a little bit a couple of years ago using the bus time archive, which is one of the precursors that you mentioned, and ran into some of the same frustrations. I was wondering, sort of to step back, if you could just remind me or to think through, like, what are the things, the questions you really want to ask with that data? And like, that's my main question, is sort of like, I think it's cool and I love using the data. I found it incredibly frustrating when I tried to use it. And then the other question is like, and I think this is a dumb question I'm going to ask, but I just want to make sure. Why doesn't the MTA have an archive of this data?
Okay, first question. I think we had a cluster of questions that we were knew potentially had legs because of the pandemic changes, all the things that I talked about in the beginning. There were a lot of things happening with travel speeds, both as the shutdowns had occurred and then as the city was going through its various gyrations of reopening. There were all of these system improvements that were happening. And then there was all of this new sensor data that was both informing sort of perennial questions about travel volumes, as well as crowding conditions related to the pandemic and how people might be responding to that. So I wouldn't say we went into it, with a set of clear hypotheses, but it was more a collection of hunches and a real desire to drive the urban tech program forward. Like I said, with data that wasn't necessarily cleaned up and tied up in a bow for these students, but more reflected the mess that they were going to find when they go out into the world and work with real urban systems. Personally, my motivation was the travel speed one. So, that has really been the focus of the bus advocacy campaign nationally for a long time, is improving bus speeds. And that is the central equity outcome as well. And the thing that, is proven to bring people back to bus systems is to improve travel speeds. And it's where New York has probably underperformed the most over time and relative to other cities as well. So that was kind of what drove it for me. What was the second question about the data?
Yeah, that just.
Why doesn't the MTA keep an archive?
Yeah, why do you have to scrape this data or continually pull it from the API, right? When the MTA is gathering this data.
Yeah. That's a good question. I know that they use it. You can tell from some of the metrics that they publish that they're compiling it based on historical data. What I do know is that the people that built the API, it's kind of on autopilot. I suspect that it's being managed, maintained with a skeleton, contractor crew. It's got, nothing's being invested in it. So, that's one of our goals is, and it's being scraped and archived by a lot of private sources. I think one of our goals is to become like a canonical public record of it. So we're trying to figure out how to do that like reliably at a low cost, because it can get quite costly to maintain this stuff.
Thanks.
There was a question so long ago now from Catherine Bejo, who asked Anthony about the density of the data and whether like kind of what parameters are in there, and how individuals might capitalize off of their own data.
Yeah, the one thing I wanted to respond to that was just that we're not collecting any data about individuals. So the unit of analysis is a bus observation. So it's like you're on a street, you see a bus go by, and that's sort of the digital equivalent of that. There are occupancy sensors on about a third of the buses that measure the total number of people that are on the bus at any given moment, but it doesn't identify unique individuals. So if you board a bus one day and board a bus the next day, you're not being tracked across those. So we have no personally identifiable information, with the exception that I think the bus operator number. So I think we can track drivers throughout the data. I know the New Jersey data has that, but I haven't looked at that. So,
I mean,
and that can potentially be super controversial, but we haven't looked at it.
Right.
Sorry.
I think there's something maybe interesting in the contrast between what you're saying there and like the work that Ryan's talking about, where you're looking at individually sourced, like having the community collect the data and share it. And so is there something interesting about like maybe having the potential to overlap data collection sources to help validate and look at things where there might be holes?
Yeah, no, I mean, like if you look at some of the private players that have done, say, like crowding, transit crowding, they're almost always calibrating their models with like user surveys. So when Google launched their crowding product, you would randomly get like, how crowded is the vehicle that you're on now? And they were, calibrating their models by using crowdsourced responses. And I think there's a lot of opportunity to do that kind of stuff. I mean, we haven't looked at creating that kind of loop. Like, would there be a time and place where we'd want to deploy some services to riders that they might be willing to return data to us, and for the value we've given them?
Mm-hmm.
I think that's maybe a whole nother set of projects.
Yeah. Ryan, do you see some difference between the crowdsourcing that Anthony's talking about and the community data collection that you were talking about?
Yeah, I mean, I think the biggest difference is it's almost the example that I'm aware of in DAR is more akin to a citizen science, even though it's sort of citizen social science, because it's there's training involved, and the data collection apps have sort of a preset list of questions. It's not, yeah. So I think it's more in the intention of the data. It's highly intentional, and people are going around and sort of asking questions and drawing points on prescribed on maps as prescribed, rather than the crowdsourcing, which is more of, I think, kind of ticking a button.
I was kind of fascinated by the shift in your project from, we're going to do all this remote sensing to, well, we're just going to have people tell us where the water is. Because I think there's definitely, when I started pushing the students to go out and go into the field, some things that had really puzzled them about the data just were immediately obvious. Like, oh yeah, it's the bus is making a left turn into traffic, or there's been a construction site protruding into the bus lane for the last 6 months, or and I think it really highlighted for them in a tangible way the shortcomings of coming at this from solely from that remote sensed perspective.
Yeah, I think it comes back to this issue of having the technology drive the questions, and having the questions drive the technology. Because if the question was just where does it flood, that turned out to be a pretty easy question to answer.
Did you feel like after you came to that the original approach was no longer valid or worthwhile, or did they sort of complement each other?
Well, they're kind of progressing on separate tracks now. There's one of the tracks will be my dissertation fieldwork looking at risk perceptions, where I think even the question of where does it flood was defined flooding and flood risk from kind of the World Bank's perspective and from the funders' perspective. And there's this separate track of the project that's still doing machine learning and sort of remote sensing to expand the digitization of building footprints. So they're kind of, they're both progressing on sort of parallel tracks. So I think it'd be interesting to see how they link up, or what kind of dialogue there is between those two.
Yeah.
I see Sharon now, and I think that's our beautiful sign that our time is up. Sharon, I want to say thank you so much for setting up this panel. I think everything was really, each of the panelists was really amazing, and it was a wonderful set of themes to consider together. So thank you for your really great work there.
Thank you. I really enjoyed the connection between the lectures and the conversation at the end. Thank you very much, all the panelists. And we are going to take a little break. I know that as the day progresses, people are getting Zoom fatigue, but we do want to keep you awake in Israel. Go and put your kids to sleep and then come back to us at 9 p.m. or 2 p.m. here in New York time. We are having a very fascinating session with both Wendy, who is talking about her research, and me, and Anthony will be the moderator. And we have a panel about visualizations and simulations. So it's going to be very exciting. So please come back. And as I said before, we have the breakout coffee room. If you want to join us to this room, it's in this link that you can now see. And that's it. Let's meet again at 2 p.m., 9 p.m. in Israel. See you later.
Thanks all. Thanks.
Sharon, maybe you can copy and paste that Zoom into the comments again.
I will.
Sorry, the chat, so that people can.
Yeah, and also remember to log in from your phone or something like that, so you will not get cut out from this meeting.
Right.
Bye.
See you soon.
רון, כמה זמן הפסקה יש לנו?
חצי שעה.
חצי שעה, חוזרים ב9.
רגע, אני מנסה להעתיק את הזום לינק.
תהיי שם בחדר קפה?
אחרי שאני אכין לעצמי קפה, כן.
ביי.
ביי.